Welcome. In this course, we'll turn ISO IEC 42001 from a written standard into working AI architecture, governance, risk controls, MLOps evidence, and certification readiness. The focus is practical, helping you lead implementation in real AI and generative AI environments. Think of the course as an implementation journey. We begin with ISO 421 foundations, then move through governance, architecture, MLOps, security, audit readiness, and a capstone case. Plan for about 40 to 60 hours depending on how deeply you engage with the hands-on work. The course is built as a system, not a checklist. First, we establish what ISO 42001 is trying to achieve and how an AI management system works. Then we add governance through risk, accountability, and regulatory alignment. From there, we design controls into real AI architecture, operate them through MLOps and incident processes, and collect evidence that proves effectiveness. The capstone brings these pieces together and shows how architecture-led implementation supports certification readiness. You can use this course effectively from several starting points. If you are newer to the topic, move in sequence and let Module 1 build the language and mindset. If you are intermediate, connect the governance concepts to architecture, controls, and operating templates. If you are advanced, use the course as a reference for turning requirements into evidence and procedures. Throughout, keep an implementation notebook and keep asking, what would I need to show an auditor? With the orientation in place, we'll begin with the foundation. Why ISO IEC 14201 exists, what an AIMS governs, who it applies to, and how architects turn requirements into practical controls. Traditional IT controls often assume systems behave in predictable, traceable ways. AI can be different. Models may change with data, rely on external services, produce uncertain outputs, and affect people, compliance, security, and trust. ISO IEC 42001 helps turn that complexity into a managed lifecycle with clear ownership, risk controls, evidence, monitoring, and continual improvement. For architects, it connects governance requirements to practical design decisions. An AI management system is the operating model for responsible AI, not just a binder of policies. It connects objectives, risks, controls, roles, processes, evidence, metrics, and improvement into a repeatable way of working. That structure helps the organization answer practical questions. Which AI systems matter? What risks they create? Who owns decisions? What controls are needed? And what proof shows those controls are working? In ISO 421, this becomes the backbone of implementation. Scope in ISO 14001 is a management decision, not an assumption. An AIMS may cover specific AI systems, business processes, data pipelines, model services, and operational activities. It may also include interfaces with providers, integrators, platforms, and regulators, even when those parties sit outside direct control. Architects make this boundary precise by identifying integrations, data flows, ownership, dependencies, and lifecycle responsibilities. So governance reflects how the AI capability actually works. A strong implementation starts by making the AIMS explicit. First, define the purpose: certification, regulatory alignment, trustworthy governance, risk reduction, or consistent controls. Next, identify what is covered, from AI products and GenAI apps to ML pipelines, platforms, and business domains. Then draw boundaries around responsibility, including internal components, vendors, cloud services, foundation models, APIs, and human decision points. Weak scope weakens evidence. Clear boundaries make control mapping, risk treatment, and audit preparation much stronger. ISO IEC 42001 becomes real when governance requirements are engineered into the AI lifecycle. Data needs lineage. Preparation needs quality gates. Training and fine-tuning need approval controls. Evaluation needs validation evidence. Deployment and inference need oversight, security, and transparency. Operations need monitoring for drift, bias, degradation, misuse, and incidents. Improvement depends on audit logs and lessons learned. The architectural question is simple. Can the system prove that responsible controls are designed, operating, and improving over time? ISO IEC 426001 does not require the same governance model for every AI system. Control intensity should increase with impact, uncertainty, data sensitivity, and legal obligation. A low-risk internal recommender may need light monitoring and simple records. A healthcare decision support model needs stricter oversight, auditing, security, explainability, and evidence. The architect's role is to translate risk into practical design choices, balancing speed, cost, innovation, and accountability. Governance becomes operational when it leaves an evidence trail. Policies matter, but auditors need to see scope, inventories, risk and impact assessments, model documentation, data lineage, monitoring, oversight, incidents, changes, audits, and management reviews. The design principle is straightforward. Evidence should be produced by the way the organization normally works. If teams have to reconstruct it before an audit, the aims is not yet operationalized. ISO IEC 42001 is the operating system for AI governance, not a replacement for every other framework. ISO 27001 strengthens security around data, models, and platforms. ISO 23894 and the NIST AI RMF deepen AI risk practices. The EU AI Act and privacy laws define legal obligations. Enterprise architecture turns controls into design standards. Together, these frameworks give 420001 the structure, evidence, and integration needed to work in practice. Consider an employee policy assistant using RAG. Under ISO 42001, governance is part of the design. Scope includes the app, retrieval pipeline, documents, model provider, and business process. Risks drive controls, such as access checks, citations, prompt injection defenses, filtering, escalation, and monitoring. Evidence proves those controls are in place through inventories, assessments, evaluations, logs, dashboards, and incident procedures. You've completed the foundation. ISO IEC 4221 uses a management system to govern AI responsibly. And AIMS connects policy, risk, controls, evidence, and improvement. Scope defines what is governed. For architects, the standard becomes real through design decisions. Next, choose one AI system and ask, is it in scope, clearly owned, and supported by evidence?